today's session we are going to see about the next exercise on your information retrieval technique. Your next exercise is going to be a term weighting. The term weighting, we are going to have various set of methods that can able to be adopted in your information retrieval process. So the various methods are Boolean, term frequency, normalized term frequency, inverse document frequency, and term frequency with inverse document frequency. So these are the various methods we are adopting in your information retrieval process. As of a first method, Boolean method, by the name itself it denotes that it is going to be having a binary value of 0 or 1. We are just going to assign for the terms that are present in the document to be 1, and for the terms which is not present in the document is going to be 0. So assigning either 0 or 1 to the method is going to be your Boolean method. This at the very early stage of your information retrieval, they have been started off with this method. Then we have been adopted for your term frequency. Since Boolean method, they have various drawbacks related to the partial matching. We cannot able to have any partial matching over to the retrieval of documents. So we are going for a term frequency. We are just going to assign some weights for the particular term in the document. So for assigning the weights, they have been initially started off the count. We are just going to find how many number of occurrences that have been happened for that particular word or the term. So count going to specify the number of occurrences for the term in the document. And the next, not only the count we are going to refer it, we are going to have the length of the document. So length of the document which carries out, you can able to have an increase in the number of words. So with that words, how much weightage I can able to give it to a particular word, that is going to be a normalized term frequency. So term frequency in a normalized way is going to have the frequency of the word divided by how many words that exist in the document, the sum of all the documents that exist in the particular document. So TF is going to be the term frequency of term T in the document D, and FT is going to be the count of term in document D, and the sum of all the frequency of the count of document of term in the document is going to be the total number of words in the document. And the next method is going to be your inverse document frequency. So inverse document frequency is not only a single document we are going to consider for the retrieval process, we are going to retrieve n number of documents from the source. So you will be having a document corpus. So if I am going to have a document, it is going to be a single document, a document. When it is going to be a collection of documents, it is going to be a corpus. So from the corpus we are going to identify the set of term which is being there in the document or not. So for that we are going for the inverse document frequency. So for that the formula is going to be log of n divided by document frequency of that particular term. So IDF is going to be inverse document frequency, n is going to be the total number of documents. So total number of documents is going to be the corpus, document corpus. Number of, if it is going to be 1000, it is going to be 1000. So we will be seeing how we are going to have this total number of documents. Okay, so total number of documents is going to be the number of documents that exist, overall exist, and TF is going to be the number of documents containing the term T. So now when we have document frequency, if the term doesn't exist in that particular document, it is going to be 0. So to avoid that 0 factors, we are going for the smoothing way. So smoothing is we are just going to add 1 to the numerator as well as the denominator, and we are just going to add it as a final concept. So this is the smoothing way of your inverse document frequency. Similar to your normalized term frequency, we can able to have your smoothing or normalized inverse document frequency. Next we are going to see about the term frequency, inverse document frequency. We are just going to combine these two terminologies as a single method. So we are going to have a term frequency to be considered along with the document corpus, the entire document corpus. So term frequency, you are aware of that the number of occurrences for that particular term in the document divided by the total number of occurrences of the words in that particular document, and inverse document frequency is going to be your number of documents that present in the corpus divided by the document frequency of that particular term. So you can able to calculate the weightage for each and every term that lays in the document corpus. Next we can able to see how we can able to practically implement in Python. As a practical implementation, we are going to see about how we can able to adopt the various weighting methodologies for the term in the information retrieval process. So we are going to have as an initial stage, we are going to find how we can able to read the content from the document. So we are just assigning and initializing a list as documents, and we are just going to specify the path to which my set of documents that exist. So documents 1 is going to be a folder where you can able to find all the set of text files in that particular folder. Okay, so this is the folder to which all the set of documents we are going to have to it, and we are just defining it to be a folder path. So folder path is nothing but the path that associated with or the document that have to be considered for the processing. And using this folder path, we are just going to identify what are the files that exist in that particular folder. So using OS, so previously we are supposed to import OS have to be there. If not by mandate, it is going to take into consideration of your directory file. Okay, so library OS, from the OS library we are just going to have list directory method to identify what are the files that exist in that particular folder. Okay, so we are going to map it to a file name. So if that particular file name ends with .txt, we are just going to locate for only textual documents. So previously we have been seeing how what are the various data sources that the information retrieval handles. So the data sources can be your text, it can be your web, or it can be your semi-structured document, it can be a structured document, anything. So here we are just going to consider for only for text. Okay, so we are just checking for whether the file name ends with text. If is it so, we are just going to open that file, okay, with open, okay, os.path.join folder path that file name. So the parameters which you have been passed is the folder path. Folder path is nothing but the corpus that exists, okay, and your file name. So here file name, it is going to reside on its own. The file name is going to be the first file, okay, file number 1, and you are going to read it in the read mode, okay, and encoding it to a normal UTF-8. It is going to be a standard textual format where you can able to find it in all the textual processing part, encoding of UTF-8 as file. You are just going to have opening a text file, opening it in the read mode, encoding it to a proper format, that is your UTF format, and you are assigning to a file. So when you have been assigned to a file, this file can be used to read it. So using read method, file is your object, you are just going to apply the particular read method to it. So once you have been applied this, you can able to append this to the documents. So documents here is going to be a list, we are appending all the file content to that list. You can also display it. So using for I, you are just initializing a variable I, and doc in enumerated set of documents. So documents is going to be your list. In your enumerated list, you are just going to have the display of your information. So what is my information? I need what is my document, how many documents are there. So initially we are going to start up with 1, okay, and we are just going to list out the words to it. Okay, this is for formatting purpose. Okay, so we are just going to read the content of the file using this sample code. Just running it. So we have document 1. Document 1 have the information retrieval is the process of finding the information, and document 2 it has some contents which is going to be your term weighting techniques, improve retrieval accuracy, and the third document is going to be the term frequency and inverse document frequency is a popular weighting technique or a method. So this is the content of your document. Now we are going to apply the various term weighting factors over to the document. So to applying your term weighting strategies, we are first adapting for the Boolean model. So Boolean model we have been mentioned as it is going to be 0 or 1. So for applying a Boolean model, we can able to find in a normal way. You can able to find the occurrence of the particular term which is going to be there or not. If not 0 or 1, this is the other way. The alternate way is we are just going to have a built-in functions to be incorporated. So your built-in functions you can able to take up from the library sklean.featureextraction.txt. From this library we are just going to import that count vectorizer. So count vectorizer where you are going to have a vectorization form of or vocabulary of your terms that you can able to collect it, okay, and group it. Your count vectorization is going to be a bag of words. Okay, so in your bag of words I can able to find out the set of documents that are set of terms that are available in the corpus. Okay, so using the voice this we have been seen in previous code itself. So to open the file from the path, from the directory, we are making use of the OS. And para for the formatting structure we are using pandas. In our code we are using as PD. Okay, so count vectorization is a method we are going to adopt it for the Boolean model so that we can able to identify the bag of words. Okay, so not only the bag of words, we can also adopt a additional weighting schema also to this count vectorization. So initially we are going to build it for the Boolean model. Okay, so this is very important. So this count vectorization has been taken up from the sklean library with feature extraction .txt. Okay, so next, as an initial stage we are just supposed to define the folder path. On defining the folder path we are just going to read the text files that are available under that folder path. Okay, so initializing the list and opening the directory, okay, as file name. So ensuring that your file name ends with txt. If is it so, we are just going to open that file in a read mode and encoding it in a UTF file format and reading it as a file. As file is going to be a variable. We are just going to assign this method. Open method is going to return a file and you are just going to save it as an object. So this object I can able to have a method to be used to read. So read method we are just going to read the content of the file and going to append it in the documents. So documents is here a list, empty list. We are just going to append all the contents of the file to the documents. Okay, so initially it is going, if it is going to read the file 1, it is going to be a list of 0. List 0 is your file 1 and list 1 is going to be your file 2, and similarly it process on. Okay, we are just going to display the content prior to the method, boolean method. Now we are going to adopt the boolean method. For adopting your boolean method, you are supposed to make use of the count vectorizer. So in your count vectorizer, there are various parameters of it, similar to your encoding or which type of term weighting factor you are just going to make use out of. You just explore it, what are the various parameters that you can able to adapt. But in this boolean model, only this parameter can able to be used. It's going to be a binary where we are just going to assign either 0 or 1. We are just making use of this parameter to be true. Okay, so that we are adopting a count vectorizer, a model for a boolean purpose. Okay, so this we are initializing to a variable vectorizer, or in other words it is going to be an object. Vectorizer is an object. Okay, so vectorizer as an object, we are identifying it to be a count vectorizer. Okay, so to further process it, we are just going to have a fit and transform of the documents to array. So vectorizer, we have been stated it as a count vectorizer. Okay, it is going to be a collection of words or a bag of words. We are just going to adopt this object for the method of fit and transform. Fit and transform is the entire whatever the documents which are going to pass it out, we are just going to map it for this method, which is going to be a count vectorizer method. Not only we are just going to have the processing, we are just going to convert the entire set of documents, not only mapping it to the particular count vectorizer model, we are just going to transform it to the boolean method also. So once you have been transformed, it is going to be an object, it returns an object. To have a conversion of that particular object, we are going to have to array. Okay, to array, it is going to list out in terms of array format. So object has been converted to array form in terms of to array method. Okay, so boolean matrix is going to have values to those terms that are associated. Okay, and we are just going to identify what are the terms that are associated for that particular object vectorizer. So here we have been transformed. Okay, this object has been transformed. You can also explore what are the terms that are associated for that particular object using get feature names. It is going to list out all the terms that are associated for that particular object. Once you can able to identify all the terms, you can able to convert it to a readable form. So the readable form is using your data frame from pandas. We are just going to convert it into a structural form. Okay, so pd dot, the method is going to be data frame, and what is the value we are going to assign it, we are going to take it up from. The boolean matrix is going to be, we are going to take it up from, and the columns is going to be the terms, the set of individual term, okay, is a column, and we are going to index it in terms of the document. It is going to be the row. So we are indexing in terms of the row wise. So if I am mentioning like this, it is going to represent each row with the set of the value which has been assigned to that particular term. Okay, we are just going to print the structure. So as of now, we have initially started off with how we can able to import, okay, what is my library to be incorporated for my model, okay, and we are just going to initialize it in terms of file reading purpose. The data source have been prepared. Once the data source has been prepared, we are just going to mention what method we are going to use. Here the method used is your Boolean method that we have been figured it as binary true. Once you have been initialized your method as a model, the count vectorizer model, we are just going to have that transformation of that particular document. The document has been mapped to that particular Boolean model and have been transformed. Okay, once we have been transformed, it is going to be an object. We are just going to convert to an array, and we are just going to identify that list of terms using vectorizer.getFeatureName, and that set of terms with the calculated value, we are just going to convert it to a structured form. So Boolean matrix, which is going to have the computed form of entire set of terms, and we are just going to convert it to a matrix representation, a readable one, using pandas. Okay, I can run this code. So the document 1, we have set of information. Document 2, we are having the set of content. Document 3, and this is going to be the words that exist in the documents. So it is going to be bag of words. When you are going to have a count vectorizer, it is going to be a bag of words, a vocabulary. So all those vocabulary will be listed out in your column. Okay, that is, your column is going to be the terms where we are extracting the feature names from the object. Okay, it lists out all the words. Okay, from all the words, we are just going to identify for in this particular document whether the term exists or not. If the term is not exist, it is going to be 0. If found, it is going to be 1. Okay, so this is a normal process where you can able to find whether the term exists in the particular document or not. Okay, so the major drawback is if the word is not there, it is just going to skip it out anyway. So partial matching won't work in your Boolean method. So to overcome this only, we are going for the term frequency. So we are going to make use of the same count vectorizer part. The same procedure has been followed up. Okay, initializing the libraries, and we are defining the data source to be prepared. Okay, then we are going for the count vectorizer method. As we said that we can able to pass the parameters to the count vectorizer. As of in this, then we are not going to specify anything. By default, it is going to be taken up as a bag of words. Okay, count vectorizer by the name itself denotes that count. Only by default, it is going to have the frequency of words for it. Okay. Once we have been initialized the model, for this we are supposed to transform the source to that particular model. Okay, so listing out of all the documents, the content, we are just going to map it to the model, the count vectorizer model, and we are just going to transform it. Transform in the sense that mapping and adapting to that particular strategy is the transforming. Once we have been done, we can able to have that conversion of to array. Since it is an object, we cannot able to directly use that object. We are supposed to convert to an array. So now we can able to list out the occurrence term, number of times the word occurs have been listed out as term counts. And what are the terms that are there in the vocabulary? Objects dot get feature names. We are just going to list all the terms, and we are just going to print it in a readable form. Okay, so when I am running this, the data source, you can able to find the number of occurrences in that particular document, only for that particular document, not across the corpus. So term frequency is, we are just going to find out the occurrence of words under that particular document. Okay, so information has been repeated twice in document 1. Okay, others are going to be a single count only, single time occurred. Okay, this is a term frequency, and you can able to adopt it is a normalized term frequency with normalized formula. So for a term frequency normalized formula, we are just going to have, so normalized is, what is the need of going for a normalized is, whether the term that there will be a number of words, we are going to consider the length of the document to it. Okay, not only the frequency, we are just going to consider along with the length of the document. Okay, for identifying the length of the document, the same procedure we are going to follow it out. Okay, as count vectorization method. Okay, the model. For this method, we are just going to have the frequency of occurrence of the particular word to be taken up. Okay, and once we have been initialized the method, we are just going to transform the initial list to that particular method. Okay, using the object, a tracer object. Once we have been transformed, we are just going to make it use of an array. Okay, and this is our normalizer part. Okay, so normalizer part in the sense that we are just going to take it out for the entire document. So previously we can see that this is going to be the entire document. Okay, for the entire document, we are just going to take this information for the entire row count. We are going to take it, and we are just going to sum it out. We are going to find the sum of axis 1. Axis 1 is going to be the row initializer. Okay, row wise we are going to find it out the sum. Okay, and we are going to have the representation as it is. Keep the dimensions as it is. Okay, don't make any changes to the when I am going to have the sum. Okay, so here this is the part we have mentioned already. It is going to be the term frequency, finding out the occurrence of terms in that particular document. Along with that, we are just going to divide it by the sum of all the terms that exist in that particular document. Okay, and this is going to be stored in the term frequency matrix. So now we are going to list out what are the terms that exist in the vocabulary or the bag of words using vectorizer object dot get feature names method. Along with that, we are going to convert it to a readable form. So having a data source and making use of the term frequency with normalized one, we can able to find out that with the length of the documents. So length of the document is going to be the number of words that exist as a overall in a particular document. Okay, this is the third strategy that we are adapting for. The fourth one is the inverse document frequency. So inverse document frequency is across the corpus. So this is individual, as an individual document we are calculating it. Now we are going to have across the corpus. So for finding out the across the corpus, we are going to make use of the TF-IDF vectorizer. So as of TF-IDF vectorizer, we are going to take it up from sklearn dot featured underscore extraction dot text. So from this we are just going to adopt the term frequency inverse document frequency vectorizer, and for structured representation we are going for the pandas, and for opening the folder we are just going to make use of the OS. Okay. So once we have been prepared the data source, open the file, we are just going to initialize what strategy we are going to adapt it. So here the strategy we are going to adapt is the TF-IDF vectorizer. So in the TF-IDF vectorizer we are going to use IDF. So use IDF is going to be a inverse document frequency. that we are going to assign it to true. So vectorizer is an object. So for a vectorizer object, we are just going to pass the documents, okay, map it, not only mapping it to that particular model or the method, we are just going to transform it, okay, and the value will be stored in a TF-IDF variable. Okay, you are just going to extract the IDF values to it. So for extracting only the IDF values, we can able to make use of the object dot IDF underscore. Since we have been making it true, we can able to extract the particular IDF values. Okay, we are going to extract what are the terms that are associated in the vocabulary, and we are just going to print it out as the listing of the terms with their IDF values, and we just going for the sorting the values in terms of IDF value, and ascending is going to be false. Okay, ascending in false is going to be in the decreasing order. Okay, so data source, you are having your vocabulary of terms. So 0 is going to be the term is going to be all the set of words that are associated in the corpus in the folder, and this is where we are listing out. It converts, it make use of the IDF. So IDF, it has its own separate formula to calculate it. Okay, so this is a bag of words in terms of inverse document frequency. So next one, we are going to adopt it for the TF-IDF. So TF-IDF is the frequently used strategy that we are adopting for importing the libraries and preparing the document for the model to be followed. Okay, initializing what strategy we are going to adopt it for. So TF-IDF vectorizer, this method we are going to adopt it for, okay, as a vectorizer object. Using this object, we are going to map to that particular TF-IDF vectorizer. Not only mapping it, we are going to transform all those values that are present in the documents in the list. We are transforming it and assigning to a variable. Okay, it is going to be a value. We can able to print it. Okay, and we are just making use of the get feature names. We are going to have this to list out what are the terms that are associated in that corpus, listing of the terms, and this is going to be the object. We are supposed to convert to array. So converting to an array and displaying it in the structured format. So we are making use of the document file to be listed out, and using your zip method. Zip is nothing but you are just going to map the term with the document. Okay, term is, it is going to list out all the terms that exist in the corpus, and document is where we can able to have list of documents, document 1, 2, 3, 4, fourth set of documents that exist. This is going to be the vocabulary, and this is going to be the document list. For those lists, we are just going to assign the weight for it. Okay, so using this, using TF-IDF matrix, we are just going to assign a particular weight to that document. So we are just keeping out for the weight equal to 0, since there might be a number of terms that holds weight equal to 0. We are just avoiding it and just identifying what are the words that exist in the particular document. So in your document 1, we have the set of information. This is as a early stage we are opening the content and reading the content of it, and this is the term matrix. So term matrix, this is the TF-IDF matrix. So we have just printed out. It is going to be an object. So 0 and 1, the first 0th row and first column is going to be your value is going to be 0.33. So for each and every word, so information has been treated up as the first column and the 7th column, 9th column, so on. So we have identified this as a document matrix, and for those identified one we can able to list it out in terms of terms. So in terms of terms, the weightage has been given as this. So weightage is in terms of TF into IDF. We are calculating the frequency of occurrence of the word, and we are identifying the inverse document frequency, and we are just going to have the product of those values to it, and we are just going to have the end result. So this is the TF-IDF values for the entire corpus. Okay, so this will be further taking up for how we can able to make it use of for searching and retrieval, how we can able to rank using this technology. We will be seeing it in upcoming sessions.